What is 1 minus sine square theta? It is cos square theta. Cos square theta under square root becomes cos theta. So we know that 1 can be replaced with tan pi by 4. Then it becomes tan A minus tan B divided by 1 plus tan A tan B, which can be written in the form of tan A minus B. If I take A square outside the square root, then I'll get A. So under the square root, I'm left with 1 minus sine square theta. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In today's session, we are going to take up few problems related to the properties of inverse trigonometric function. Let's solve those problems. The first question is we have to find the values sine of pi by 3 minus sine inverse of minus half. From the property sine inverse of minus x can be written as minus sine inverse x. So here in the place of sine inverse minus half, I can write it as minus sine inverse half. So here this becomes sine of pi by 3. Minus of sine inverse means minus into minus becomes plus sine inverse of half. Now for what values of sine, we will get it as 1 by 2. So the value of sine is 1 by 2 for sine pi by 6. That is sine 30 degree. Now we have here sine inverse of sine. So when you have sine inverse of sine theta, then this can be written as theta. One more property of your trigonometric function. So here we will get sine pi by 3 plus pi by 6. So pi by 3 plus pi by 6 60 plus 30, which is 90 degree, which becomes sine pi by 2. What is the value of sine 90 degree or sine pi by 2? It is 1. So the value of this function is 1. Next, we have sine 2 cot inverse minus 5 by 12 here. So here sine, let me take cot inverse 5 by 12 as theta. So I'll take this as theta. So that is I have taken cot inverse minus 5 by 12 as theta. Then cot theta becomes minus 5 by 12. So from the triangular property, if this is your theta, then cot theta is adjacent by opposite. So adjacent is 5, opposite is 12. So now this will become 13. The hypotenuse is 13 from Pythagoras theorem. So we know that sine 2 theta can be written as 2 sine theta cos theta. So now from the triangle we can write sine theta as, we can write opposite by hypotenuse and cos theta as adjacent by hypotenuse. So now let's substitute the value here. We will get 2 sine theta becomes 12 by 13 and cos theta becomes 5 by 13. So 12 5 is 60 into 2, 120 divided by 169. So this is the value of the given function. Next, show that sine inverse of 2x square root of 1 minus x square is 2 sine inverse x and x lies between minus 1 by root 2 to plus 1 by root 2. So here let us consider the left hand side. So sine inverse 2x root of 1 minus x square. So let us take x is equal to sine theta. If x is sine theta, then theta becomes sine inverse x. So wherever you have x, substitute sine theta. So this is sine inverse of 2 sine theta root of 1 minus sine square theta. So what is 1 minus sine square theta? It is cos square theta. Cos square theta under square root becomes cos theta. So here you will get this as sine inverse 2 sine theta cos theta. What is 2 sine theta cos theta? It is sine 2 theta, and outside you have sine inverse. So sine inverse of sine theta is theta itself. So therefore sine inverse of sine 2 theta becomes 2 theta. So here replace theta by sine inverse x. So then this is 2 sine inverse x, which is RHS. Next question. Show that sine inverse of 2x square root of 1 minus x square is 2 cos inverse x. So here also let us consider the left hand side. So which is sine inverse of 2x root of 1 minus x square. So let us take x is equal to cos theta. Then this implies theta is equal to cos inverse x. So now wherever you have x, just replace with cos theta. So this becomes 2 cos theta root of 1 minus cos square theta. What is 1 minus cos square theta? Sine square theta. Sine square theta under the square root becomes sine theta. So this is equal to sine inverse of 2 cos theta sine theta. So this is same as 2 sine theta cos theta, which is sine inverse of sine 2 theta. Now sine inverse of sine theta is theta itself. So this is 2 theta. So theta is here cos inverse x. So this is 2 cos inverse x, which is the right hand side. Next question. Show that 3 sine inverse x is equal to sine inverse of 3x minus 4x cube. So here let us consider the right hand side, RHS. So sine inverse of 3x minus 4x cube. So let us replace x by sine theta here. So x is equal to sine theta. So this implies theta is equal to sine inverse x. Now this becomes sine inverse of 3 sine theta minus 4 sine cube theta. So 3 sine theta minus 4 sine cube theta is your sine 3 theta. Now outside we have sine inverse. So sine inverse of 3 theta is 3 theta. Sine inverse of sine 3 theta is 3 theta, which is 3 sine inverse x, which is LHS. Next, 3 cos inverse x is cos inverse 4x cube minus 3x. Since every function is in cos, let us take x is equal to cos theta here. So let's take the right hand side, that is cos inverse of 4x cube minus 3x. So let us take x is equal to cos theta, then theta is cos inverse x. So here it becomes cos inverse of 4 cos cube theta minus 3 cos theta. 4 cos cube theta, 3 cos theta is cos 3 theta. So cos inverse of cos 3 theta is 3 theta. So which is 3 cos inverse x, which is the left hand side. Next one. Write the following function in its simplest form. So here it is given in the form of a inverse trigonometric and trigonometric form. We have to reduce this into simplest form. So here tan inverse of cos x minus sin x divided by cos x plus sin x. X lies between 0 to pi. Now tan inverse of, I'll divide both numerator and denominator by cos x. So then this becomes 1 minus sin x by cos x is tan x here. Cos x by cos x is 1. Sin x by tan x is tan x. So what I have done here, divided numerator and denominator by cos x completely. So now this is in the form of 1 minus tan x divided by 1 plus tan x. We know that 1 can be replaced with tan pi by 4. Then it becomes tan A minus tan B divided by 1 plus tan A tan B, which can be written in the form of tan A minus B. So this can be written as tan inverse of, instead of tan pi by 4, I can write this as tan of pi by 4 minus x. Now we have here tan inverse of tan pi by 4 minus x. So tan inverse of tan, here the value will become pi by 4 minus x. So this is the value. Next one, tan inverse of root 1 minus cos x divided by 1 plus cos x. So from the multiple angle formula, that is 1 minus cos 2 theta is 2 sin square theta and 1 plus cos 2 theta is 2 cos square theta, and this can be reduced to half angle also. So instead of 1 minus cos x, I'll write 2 sin square x by 2, and here I'll write 2 cos square x by 2. 2 and 2 get cancels, so both are square here. Under the square root, it becomes sin x by 2 divided by cos x by 2. And sin by cos can be written as tan x by 2. So therefore, tan inverse of tan is x by 2. Next question. Tan inverse of cos divided by 1 minus sin x. Here also we can use the half angle formula. So here cos 2x, instead of cos 2x, I am using cos x. So I can write this as tan inverse of, if I have cos 2x, I have written as cos square theta minus sin square theta. So here I'll write it as cos square x by 2 minus sin square x by 2. And we know that sin 2 theta is 2 sin theta cos theta. So here I can write this as 2 sin x by 2 cos x by 2. The same multiple angle is replaced by half angle, and instead of 1, I'll write this as cos square x by 2 plus sin square x by 2. Because we know that sin square plus cos square is always 1. Now here, this is in the form of a square minus b square, which can be written as a plus b and a minus b. And this is a square plus b square minus 2ab. So this can be written as, that is cos x by 2 minus sin x by 2 whole square. Now here we can see cos x by 2 minus sin x by 2. Cos x by 2 minus sin x by 2 get cancelled. We are left with cos x by 2 plus sin x by 2, cos x by 2 minus sin x by 2. So here in this problem, when you have cos x minus sin x, cos x plus sin x, we have taken numerator and denominator divided by cos x. In the same way, here we will take numerator and denominator divided by cos x by 2. So then what happens here? This becomes tan inverse of 1 plus tan x by 2 divided by 1 minus tan x by 2. So this is after dividing by cos x by 2. Next again, this is in the form of tan pi by 4. Value of 1 can be replaced with tan pi by 4. When you have tan A plus tan B, it can be written as tan A plus B. So therefore, this can be written as tan inverse tan of pi by 4 plus x by 2. Now tan inverse of tan theta is theta itself. So the value becomes pi by 4 plus x by 2. Next, tan inverse of root of 1 plus x square minus 1 divided by x. Now here put x is equal to tan theta. So what happens here? Tan inverse of 1 plus tan square theta minus 1 divided by tan theta. So what is 1 plus tan square theta? It is secant square theta. Under the square root, we have secant square theta. So this becomes only secant theta. So secant theta minus 1 by tan theta. So outside we have tan inverse. Secant theta can be written as 1 by cos theta. 1 by cos theta minus 1 divided by tan theta becomes sin theta by cos theta. So on solving this, we will get tan inverse of 1 minus cos theta by cos theta, and denominator is sin theta by cos theta. So cos theta and cos theta get cancels. 1 minus cos theta can be written as 2 sin square theta by 2, and sin theta can be written as 2 sin theta by 2 cos theta by 2. One sign get cancelled, 2 get cancels. We are left with tan inverse of sin by cos becomes tan theta by 2. So tan inverse of tan theta is theta itself. So the value is theta by 2. And theta is here tan inverse x. So therefore the value here is 1 by 2 tan inverse x. Next one, we have tan inverse of x divided by root of a square minus x square. So let's put x is equal to a sin theta here. Then theta is sin inverse x by a. So let us see here, tan inverse of x we have taken as a sin theta divided by a square minus x square is a square sin square theta. Now I can take a square outside the square root. So this becomes tan inverse a sin theta. If I take a square outside the square root, then I'll get a. So under the square root, I'm left with 1 minus sin square theta. So what is 1 minus sin square theta? Cos square theta. Cos square theta under the square root becomes cos. And here a get cancels. We are left with tan inverse of sin theta by cos theta. Now what is sin by cos? It is tan. So tan inverse of tan theta is theta. But what is theta here? It is sin inverse x by a. So this is the simplest form of the given function. Next one, find the values for the following functions. So we are supposed to find the value of the given function. The very first question here is tan inverse of 2 cos 2 sin inverse 1 by 2. So let's solve tan inverse of 2 cos 2 sin inverse. So when you have sin inverse, we should have sin, so that sin inverse and sin get cancelled and only the value will remain. So for what value of sin we will get 1 by 2? It is sin pi by 6. Now sin inverse of sin pi by 6 can be written as only pi by 6. So therefore this becomes 2 cos 2 into pi by 6. Now here this becomes cos pi by 3. So what is the value of cos pi by 3? So cos pi by 3 is 1 by 2. So now 2 into 1 by 2. 2 get cancels. We are left with tan inverse of 1. For what values of tan we will get the value as 1? For pi by 4. So therefore it is pi by 4. Next, tan 1 by 2 sin inverse of 2x by 1 plus x square cos inverse of 1 minus y square by 1 plus y square. See, if you put x is equal to tan theta here, then here this is 2 tan theta by 1 plus tan square theta. So this is the formula of sin 2 theta. And similarly here, if you put y is equal to tan theta here, then this becomes 1 minus tan square theta divided by 1 plus tan square theta, which is a formula of cos 2 theta. So therefore, here this becomes tan 1 by 2 sin inverse of, so in the place of x, if you replace with tan theta, then we can write this as sin 2 theta. Here, and here we can write this as cos inverse of cos 2 theta. So here what happens? Theta is equal to tan inverse x, and here theta is equal to tan inverse y. So for this function, sine inverse of sine, we will get this as 1 by 2 to theta. What is theta here? It is tan inverse x. And here this becomes 2 tan inverse y. And 2 is a common here. Then this becomes tan of tan inverse x plus tan inverse y. So we have one property among the inverse trigonometric function, that is tan inverse x plus tan inverse y can be written in the form of tan inverse of x plus y divided by 1 minus xy. This is the property of trigonometric functions on tan inverse x plus tan inverse y. So here if you replace this by tan inverse of x plus y by 1 minus xy. We know that tan of tan inverse x is x. So therefore, tan of tan inverse x is same, that is x plus y, 1 minus xy. So this is the value of the given function. So thus you have studied the properties of trigonometric functions and you have simplified the problems related to it. We'll meet you in the next chapter. Until then, keep watching, keep learning, keep exploring. Thank you.